Good morning, everyone. Good morning. Yesterday, I gave you a link also for the assignment number two. Uh, Everybody got that? Am I audible? Yes.
Yes, ma'am.
Okay. You got the this link for the assignment.
Yes, ma'am.
So today we'll be talking about the flat slabs. Okay, under buildings. So let me. So today we'll start a new topic, which is your flat slabs. Share. Yes. Okay. Where is the? Okay. Okay. Where is? So today we'll be starting with the flat slabs. So what are actually your flat slabs? First of all, we should know that what is your flat slabs. Flat slabs are those which are directly resting on the columns or column head without beams. These are known as your flat slabs. Okay, earlier in your previous semesters you have already gone through the slabs, the yes or no? So those were your normal slabs, conventional methods, and these are your flat slabs. Flat slabs, those slabs, the normal slabs, were resting on your beams, and from the beams they would transfer the load to the columns, etc. So, but in flat slab, what happens? There is no beams. Okay, these are those slabs which have no beams, but they are directly resting on the columns, and they are transferring their loads directly to the columns without any beams. Okay, so if I show you some pictures on this, see, these are your flat slabs. Okay, see here, there is no beam here. Here also you will see there are no beams directly there. Your slab is resting directly on the columns. Okay, and here also you will see everywhere you will see here the flat slabs are resting directly on the columns. They are not, there is no beam here. You can see here also. These are some of the pictures from the Google. Okay, so that you have an idea of what are flat slabs. So, okay, now if we go to the next slide, we have done this water flat slabs. Now water drops in panels and their uses. Before going and discussing the this thing, the flat slabs properly, I would like you to know what are drop panels and their uses. Okay, so what are drop panels? Drop panels are the rectangular portion provided above the column. Okay, above the column, where is, okay, I cannot use your pen. uh, Above the column and below the slab in order to resist the slab from getting sheared and undergo rupture. Okay. What are drop panels? Drop panels are the rectangular portions provided above the column. So if you have, this is your slab, what happens? You will have a column here because this is a flat slab, so your flat slab is going to transfer your load to the column. But what are drop panels? Drop panels are this rectangular portions which are above the column. That means this here. Then again you will have here the column. Okay, so these are your drop panels. This one, this portion. Okay. Just now you have seen some figures also on the Google. Okay, so those are your panels. Okay, now if we go to the next, drop panel increases the contact surface area between the column and the slab, which will enable a better distribution of load from slab to column. Why we use drop panels? We use such that they give a better distribution of load from the slab to the columns. Okay, thus it will reduce the chance of slab failure due to unbalanced moments. Okay, so that's why we provide drop panels. Since we are not using beams, but so that the load is distributed properly and there is no slab failure, that's why we sometimes give your drop panels also in flat slabs. Okay, so water column heads. Now next is water column heads and the uses. So one was your slab, the panels, drop panels, and the next one is your column heads. So water column heads, these are a mushroom like enlargements of reinforced concrete at the upper end of a column. Okay, so they are designed and built to act as an integral unit with the column and the floor slab so as to increase the shearing resistance. So like I told you in the drop panels, what happened, let me use my pointer here. If I use, okay, this is highlighter. So if we what are your column heads now? See, this were your slabs. Okay, so what were your drop panels? Drop panels were this, which are dropped from the slabs above the column. And what are your column heads now? Column heads are the heads of the column. Okay, so these you can say it can be circular or it can be rectangular also. So these are your columns, and above the column you have this column head. Okay, this will also help in increasing the shear resistance. So what is the use of these column heads? They are used to increase the shear strength of the slabs and to reduce the bending moment in the slab by reducing the effective span. Okay, now if we go to the next point, we see here. Now we will see what are your types of flat slabs. Okay. Slabs without, there are how many types of flat slabs? There are slabs without, the first one if we see, these are the slabs without drop and column, without column head. Okay, these are slabs without drop and without column head. Without column head, that means what? These are like the normal, these are like your normal slabs, except that this is since flat slab, so this has no beams. It is directly resting on the column. There is no drop panel, there is no column head, but these are directly resting on the column. So this is the type 1, which is slab without drop. Without drop, you see here, without drop and without column head. Then next, if you see slab with drop and column, slabs with drop and without column head. So that means what? You have this slab with a drop, there is a drop, but there is no column head. This is directly below the drop panel, we have the columns. Okay, this is the second type. The third type is slab without drop and with column head. So the third type is what? The third type is you have a slab. There is without a drop. That means there is no drop, but there is a column head. So this is your column head, and you will have here, this is the column. That means there is no column head, but there is a column. There is a, sorry, there is a, not a drop panel, but there is a column head above the column, which is your slab is resting above this two. Okay, now the fourth type, if we see what is the fourth type of the flat slabs, it is slab with drop and also with column head. That means, so this is your slab. You have what? You have drop also and you have column head also. Both are present here in this type. So you have a column, sorry, drop panel. You also have a column head. Then there is a column. So that means in this fourth type, the slab is resting on the, you see here the panel, drop panel, as well as the column head, as well as the, your slab is resting on these three. That means as a panel, drop panel, the column head, as well as the, and finally on the columns distributing its loads. Okay, since these are given, why? Because as I told you in the previous slide, that these are used, why? Because since we are not using beam and you need to distribute the load properly so that there is no shear or rupture, or there is resistance to, they can, your columns can give resistance to bending. Okay, your slabs can give resistance to bending, so therefore we use this so that these loads are distributed properly. Okay, so you can see in this figure, if it is clearly, I think it will be very much clear from this figure, the all the types of the flat slabs. You see here, this is a flat slab resting directly on the columns. As I told you in the first type, there is no column head or there is no drop panel. This is directly resting, you see here, directly resting on the columns. And in the second type, if we see slab with drop panels, this is your drop panel, rectangular, you see here, this is a rectangular drop. Okay, and below the drop, that means the drop is resting on the column. Another type is what? The flat slab with drop panel and column head. The fourth one, this was the fourth one. See here, this is your drop from the slab, and also there is a column head on the above the column. So this is the fourth type. Now the flat slab, the third one was flat slab with column head but without drop. You see here, these are your column heads. Here it is given in circular notation here. So these are your column heads. You can see your columns are above the column head, but there is no drop. So it is clear from this figure, I guess, all the types of the flat slabs. Okay, then now, if we talk about the first type, the slabs without drop and column without column head, these are directly supported by the columns. If we talk about each type in short, what will happen? The slabs, because next class we will be designing on those flat slabs we are going to design. So today I'm just giving you the theory portions of the flat slab, like what are the types, basics of that flat slab. So flat slabs without drop and column head, they are directly supported by columns. You have seen the figure. Then these are used in warehouses, offices, and public halls, which are avoiding beams. Basically, why we use why we use our flat slabs? Because this will provide us a very this thing now, the height of the floor also will be decreased with the if we remove the beams but we just keep the this thing, the columns. These flat slabs are used where we require more space in the room height. Okay, and this can be used in you can see in parking slots, then again where there is sometimes you don't require columns, much columns in some of the places. In that case also we will use flat slabs, like parking areas, you can say, or pub, marriage halls, or any kind of other offices, where warehouses where there is no requirement of much columns, etc. Okay, so basically this first type is used where? These are used generally in warehouses, offices, public halls, avoiding beams. Now if we go to the next type, was the slab with drop and column without column head. That means only with drop. Your flat slab with drop. Here the moments in the slabs are more near to the column. Okay, hence the slab is thickened near the columns by providing the drops. Okay, so here the thickness of the slab we can increase because they are near to the column. There is no column head provided above the column, so they are nearer. Your slab is nearer to the column, so we will provide will increase the thickness of the slabs of our flat slabs. Okay, by providing these drops. Sometimes the next point says what? Sometimes the drops are called as capital of the beam. Okay. Next, if we see the slab without drop and column with column heads, that means these are the flat slabs only with column head. There is no drop, as we already have talked about this. So the first point on this is what? The column heads may be provided with any angle from the consideration of architecture, but for the design, concrete in portion at 45 degree. Okay, on either side of the vertical only is considered as effective for the design. So your when you have a column head in this way, so we can give it in a 45-degree angle. Okay, when you have a column head in this way. Okay, so that should be 45-degree angle according to design. And also why we sometimes provide flat slabs. Sometimes according to some architectural point of view, you need to have a better view, and sometimes there are hindrance to the lights also, lightning effects are also missing. But in some places, suppose you are constructing a room or a small building where you need, for the purpose of that building is that you have to have clear vision of the lights. There should be clear visibility of light. There is no disturbance or by the columns which are hindering the lights to pass. In that case also we use flat slabs such that to give lesser columns and beams. Okay, so without beams, so that the lights are properly spread over the room. Then also this is the point. Then the next point, if we see the slabs with drop and column with column has, that means both the column drops as well as the both the drop and the this column head are there in this fourth type. So here, if the life load of the beam is large enough to cause excessive shear stress, enough depth should be provided around the column to prevent the shear stress from causing punching. And if the depth of the column head or drop panel alone is very large, which is aesthetically displeasing, it is better to go for drop plus column head. So why, when we provide this drop and column heads together, when we know that our life load is going to be very much high. Yeah, okay. uh, our life load is going to be very high, suppose. And also in that case, when we have a huge load to be resisted, to be resting on the slabs, what we do, if we provide only, this is your beam, if we provide sorry, this is your slab, and if we provide only drops above the column, what will happen? uh, because since the load is very high, since the load is very high, obviously you will have to, since if you're placing, if you're constructing only this, if you're giving only this drops below the slab, then what will happen? And your life load is very much high. Then what will happen? You will have to increase this depth of the either the slab or the this thing panel, drop panel. So that alone, this alone, if you give it so depth to be very much high, it will not look good. And because since drop panels or the flat slabs, we are basically providing those flat slabs. Why? Such that there is from the architectural point of view, such that there is a design is better. Okay, mostly why we provide flat slabs, to according to the architectural point of view, such that your building looks beautiful. Okay, and also you don't have to provide false ceiling there. Why we provide false ceiling? To hide the beams, so it's for a very good look of the room. But then when you use flat slabs, you don't need to have this thing, the false ceiling also, because there is no beam already. And also to decrease the room heights, excluding the beams we use for those things. So basically, why when we use this with drop and with column head flat slabs, when we have higher loads, life loads, and due to which you cannot provide, suppose you have only this slab, and if you are avoiding the column, suppose here we had talked about the drop panel. So if only drop panel we provide for this high load, high uh, quantity of load, if you see. Okay, so what will happen here? This depth you have to increase, and obviously it will not look good. And if you, same thing for the column heads also, if you only provide column head above the columns, what will happen for a large load? Okay, so this will not be able to take this, and ultimately you have to increase your this depth of the beam as well as the depth of the your this depth of the column head. So that will obviously not give the this thing na flat slabs, the use of flat slab. The use of flat slab will not be fulfilled. Okay, so we provide this drop column. Biru Zamatia, you're telling something. Okay, and if the depth of the column head or drop panel alone is very large, yeah, okay, I told you this. Now next, if we come to advantages of flat slabs, what you think will be the advantages of flat slabs according to you? Okay, so let's talk about the advantages of flat slabs. So if we go if we go to the advantages of flat slabs, the first point, if we see, the flow system requires in flat slab flow systems, we require lesser depth, and thus there will be better reduction in the story height. I mentioned you this thing. Okay, when we use flat slab, we are reducing the story height by removing the beams. Okay, next is there is a reduction in the dead load and foundation loads, since the overall weight and the story height are decreased. Obviously if you are removing the beams, and also the this thing, if you are removing the beams also, then what is happening, you are ultimately decreasing the story height. Yes or no? And overall the this thing is also decrease the dead load, or due to the beam which is going to come, that is also going to decrease. Another one, if you see, the formwork for flat slab construction is simpler and takes less time. It should be is okay. This is not in. Anyways, this is formwork for flat slab construction is simpler and takes lesser time. Flat slab construction has improved fire resistance as compared to other types of floor system. Okay. Since beams are absent, there is better illumination and the okay. There is better illumination and the plain ceiling gives better appearance, having the best property of diffusing light. So I told you this thing also, that one of the advantages of flat slab is also what, that it gives better diffusing of the light, and also the plain ceiling is provided there. You don't need to then provide or go for the false ceilings, okay, which will also increase your cost again. So you can use, this is also another advantage of flat slab. Without using false ceiling, you can directly, if you give flat slab, you can directly use that flat slab. Now also, if we talk about some of its disadvantages of the flat slabs, what are those? That drop panels may interfere with larger mechanical ducting as well, because if you give in some of the uh, suppose like in parking slots or somewhere, so there will be some kind of pipes or mechanical working instruments will be there, okay, along the walls or slabs there will be pipes, okay, the lightning wires, etc. So that may be hindered, okay, to some extent, not much but some extent also, okay, when there is a larger mechanical works, okay. And next one is not suitable for supporting brittle partitions, okay. Those structures which you think uh like suppose glass, you're making a building of glass or some brittle partitions you're using, in that case we cannot use flat slabs, they are not suitable, okay. Higher slab thickness, okay. When we reduce the when we remove the beams and we give a column head or the column the column head or the panel drop panels, what is happening, we need sometimes, and the load is very much higher, in that case the life loads are very much higher, in that case we can, sometimes we need to increase the slab height, sorry, the slab thickness, so therefore that is also one of the important disadvantage. Vertical penetrations need to avoid vertical penetrations need to avoid area around columns, okay. Sometimes in some buildings also you may have vertical penetration works, okay, according to architectural point of view, in that cases we need to avoid the area around the columns, okay, because column is taking the entire loading, and so you cannot give this kind of works above the column, so we must avoid that, okay. So thank you for this slide, but I want to show you some more like the differences, or you can say disadvantages, advantages. Let me see. I think it is not here. Let me see where it is. Buildings. Okay, Yuma. This is. So see here, I have some of your differences between the flat slabs and the slab beam system. That means this is the conventional method. Okay. Yeah. This is the flat slab system, and this is the difference between the conventional slabs with beams. So what are the first differences? If we see, we'll talk some about some of the differences. So it is in a flat slab system, the floor or roof consists of walls or slabs, and there are no beams. We know this thing. In the conventional method of flat slab, the normal slab beam system, the floor or roof consists of beam and slab. Next difference, if we see, in flat slab system, the thickness of the slab is large, but in the slab beam system, the thickness of the slab is small, while the depth of the beam is large. Got it? In the slab beam system, our slab thickness was less, but the beam which we used to provide was large. Okay. Next, if we see the type 3, sorry. Okay. Hmm. Next, if you see point number 3, flat slabs, what they do, it provides greater clear ceiling heights, and in slab beam system, it provides lesser clear ceiling heights because of the beams which with the larger depths of beam. There is no clear ceiling heights. Then we have the fourth difference. If we see here, load from slab is directly transferred to the column, but here it is transferred to the beams and then from beam to the columns. Next, if we see the fifth one, in flat slab system, less formwork is needed, obviously, because you don't have beam, you don't have this. But in flat beam system, more formwork is needed for extra beams. Then we have the sixth point. If we see, the flat slabs work in here, the formwork is simple and hence not costly. But in slab beam system, the formwork is complicated and hence costly. Okay, because there are so much of beam with the greater depths, etc. So flat slab system, drop panel is provided above column. Yeah, but in slab beam system, there is no need of drop panels above the column because you already have the beam. I have 5 minutes.
Ma'am, I have some questions, ma'am.
Hmm.
Hello, ma'am.
Hello.
Yes, ma'am, I have some questions, ma'am.
Hello. Yeah.
Ma'am, can we also have this kind of slabs in precast manner?
Hello.
Yes, ma'am. Ma'am, I said, can we also have like this kind of flat slab? Can we also have precast flat slabs?
You can have, no problem. But because your room will be so large, the size of the room. But in that case, it will be difficult to bring on the side. But on the side itself, you can make. Okay, so precast you can do here on the site. Okay, but you cannot. There will be problem in transferring the flat slab if you precast it and then bring, depending upon your size of the room. Okay, or the mostly, but I don't think it is used because we use this kind of flat slabs where in mostly in this kind of shopping malls you can see on the this thing parking slots you will see there is no beam, but there is directly resting on the your slab is directly resting on the columns on the halls, some kind of halls you will see, movie halls or somewhere where the area is large, where the area is large and you need more space, and you don't need you don't need to decrease your height of the floor due to your beam. So we use flat slabs, and therefore in large rooms we use large floors or rooms. So mostly we don't use precast here in flat slabs, but in small rooms, suppose you want your flat slab here, in your building you want your flat slab, in your veranda you want something like that. So in that cases, precast you can use in those types because those will be economical also, you know. Okay.
Ma'am, ma'am, I have one more last question, ma'am.
Hmm.
Ma'am, the previous slab, this slab beam system, it's
Hmm.
governed by just bending moment. So we just designed for bending. But so far you've been talking about shear and punching shear. So
No,
is
no,
this slab
bending also. This will slabs are all same. Bending we have to design for that also because so that it can resist bending. Obviously, there will be bending now in
so, ma'am,
slabs.
can because the previous slab, because the depth was so thick, we can use the ropes. So we provide only bent up bars. So since this depth is big, can we use stirrups in this kind of slab, or still we
No,
don't
it
provide
will be a
stirrups?
two-way. You have to use two-way system here. So on both sides, you have to use the reinforcements you have to provide. Earlier in the slab beam system, we could have given in one way. That means reinforcement was one way and the bent up bars was on their sides. So, but here in both side you have to design. Let me show you something if I can. Stop. Where is? Hmm. When we'll design, you'll understand this. Okay, we have to. Where is? Wait. Where is my this thing? Okay. Hello. Hello.
Yes, ma'am.
Oh, we are there now. So there are some